I wanted to make this discussion for some time, and I actually started writing a blog post about biomotor abilities and my opinion about them, but I kind of stopped, and I thought that making some form of video presentation or webinar a better option, because I can probably tell more in a less amount of time, and probably I guess the readers will appreciate and stick to a video more than reading 20 pages of text. So basically what I'm going to cover is my opinion regarding the biomotor abilities and classifications that are pretty common in sports science. This is, I think it's a right word, pet peeve of mine, biomotor abilities. And since I started coaching, and even before that, since I started learning or studying strength conditioning, I've been kind of interested in how did we manage to come up with those classifications when it comes to biomotor and bioenergetic abilities or qualities. You probably know what I'm talking about. If you Google it, you're probably going to see speed, ability, speed, agility, strength, explosive power, aerobic endurance, anaerobic endurance, and so forth. So I was always interested in how did those emerge, who discovered them first. And I think I had a hunch that they are basically flawed, and right now I'm able to kind of use a statistical simulation to prove it, also to myself and to the readers. So basically what I'm going to do in this presentation is tell you a bit about ontology, or basically philosophy of biomotor abilities, and I'm going to provide a simulation in R language. So how does everything start? Ontology is basically a branch of philosophy discussing what exists, or what's out there, or what's reality. It might sound philosophical or metaphysical, but basically what we are trying to do as coaches and as sports scientists is to explain certain performance. By performance, I'm not meaning referring only to a physical performance, but game performance, perceptual performance, all that's out there, so to speaking. So what we are trying to do is create ontology and explain what exists and create certain structure. On this picture you can see basically a color wheel, and inside, except for a black color, we see all the colors our eye can recognize. So we are interested, there's a couple million colors inside. I'm not so sure how much we can differentiate, but what, taking this simple example into account, what we are trying to create is some form of simplification of this. If you go to next slide, but before that, so what we have here is some form of observed performance. It might be individual, might be team, group or collective, and we are trying to create ontology, what's really out there. And I'm going to use a color wheel to explain some concepts, and hopefully that's going to make sense. So we have that physical basically performance at hand, and we are trying to understand it, and vagueness is something that we are trying to explain. The first step we do is always we do some form of a dichotomy, and then later proceed to create hierarchy or classification. And this is pretty much done in every field of human knowledge, including the sports science. Vagueness is basically the observable and non-observable performance of the athlete or group of the athletes, something that we are trying to understand. Dichotomy is a first step. Basically, we are creating two excluding components. Again, this is flawed, as we're going to explain later. I call this the root problem. What we do usually in a sport science and coaching, we kind of dichotomize performance into abilities and skill. I'm going to cover that a bit later, and then we proceed creating a hierarchy. Again, this could be strength, endurance, flexibility, and going even further, the subcomponents of each. Speaking about the root problem, as I said, that's basically the dichotomization of the performance into skills and abilities. On the picture is Yuri Verkhoshansky's famous graph, where we have the green line is basically athlete's potential, some form of a latent hidden potential, and T is ability to utilize that potential. Basically, the blue line is skill and green line is a potential. R is related to training intensity needed to bring up those improvements. So what we have here is basically visualization of that dichotomization process. So here we have a motor ability, and here we have a skill to utilize it. This might be a funny story or example, but if you ever watch movies like Rocky or Kickboxer, like Jean-Claude Van Damme movies, and he's trying to beat the opponent or improve, revenge someone or something, and usually he same thing with Rocky, he starts training. After he finds a coach, training coach or training partner or location, he starts training. But what we can see in the movie is the first thing he does, or most of the time, he always do some physical stuff. Like Jean-Claude Van Damme is doing splits, kicking the bamboo tree. Rocky is punching the beef in a butchery shop. Doing some all crazy stuff. And basically what he's trying to increase his potential. One question, in all those scenes in Rocky, have you ever seen him sparring with the opponent? I don't think so. Maybe a couple of scenes he did some sparring with a partner. Same thing with Jean-Claude Van Damme. What he's trying to do is improve his technique, kicking, punching, and all that stuff. And then he's just put into a ring and expect his skill to be improved. I mean, that's kind of represent the cultural thing we have at the moment with the dichotomization, and our opinion that if we improve the potential, the overall performance will follow. But as we can see over here, we also need to improve our ability to express or use that potential. Only at the highest levels of performance we need to think about increasing the potential even further, because our skill as athletes is our skill to use the potential is improving, and the buffer is less and less. Taking this example a bit forward, for example, if you're training a shot putter, or if you're observing or talking to a shot putter coach, especially from Western, what they are trying to do is try to increase the potential by using generalized or specialized means like incline, bench press, squat, clean, and the increase in shot put performance will follow, because they are trying to increase the underlying factors of performance. But if on the flip side we have Bondarchuk, who said crap, that doesn't work. You need to it's not about increasing a potential and then just transforming it with a couple of throws, and looking at throws as just transformation of what you have. No, he said, you need to also think about the skill, and you need to increase your I would say, I would use special strength, but I'm not so sure that's the most happiest term. But what you need to do is also think about this one. You probably already have potential, but you need to think about performing your skill and improving your ability to utilize what you already have by performing specific exercise. So speaking about mentioned example of Rocky and Jean-Claude Van Damme, what they can probably did and what will probably be needed in a real life, instead of just doing bench press and running laps and running stairs, is to engage into a specific activity, sparring, hard sparring. In MMA we have a shark pull and all that stuff that's aiming to increase the, not only in a mark's special endurance, but also increase the capacity to be able to focus for a duration of the bullet. So going back to our hierarchy, what we are trying to do with classification and hierarchy, we basically create buckets. So going back to the first slide, we have this vagueness of our experience, and we are trying to make sense of it. So what we are trying to do is, first step is we did some dichotomization to motor skill and motor ability. And then we have, creating hierarchy. In this example, you see the same color. I'm not going to color continuum, but this is a funny picture. We can see the women have different and are able to identify much more buckets than men. In this case, this is a general coach or a sports scientist, and we are trying to create different buckets and explain certain performance by using biomotor ability. So these might be a bench press, squat, upper body push, upper body pull, whatever. This could be a speed, this could be endurance. And what we are trying to put those things into a bucket and call it strength, endurance, and speed. And what we did with this is we make it more functional, a bit easier to organize things, to create some form of understanding of this vagueness just by creating certain zones. We also have similar approach in endurance training by creating workout zones. So we are always kind of splitting the continuum, making sense of the vagueness by creating hierarchies. The thing is, even if the buckets are useful from a decision-making standpoint and making sense of the stuff by reducing the dimensions, and instead of having 16,000 colors, we have using 3 main ones or 4 or less or more. What we lose is that within a certain group we lose the ability to differentiate between different components. And also, we also lose ability to see similarities between different groups. For example, I'll give you the example from a real world. We have a powerlifter and we have a sprinter. So basically, we can consider them 2 buckets. One needs strength and one needs speed, and both of them are performing squat. If you ask the powerlifter what does a squat represent to him, because his abilities and in a strength, because his strength is so high, squat represent basically a skill. It's so specific, he's gonna put a lot of details into it, taking out the equation of the equipment and everything. It's gonna be a stance, up, high or low position, all that stuff comes into play. With the sprinter, squat is just one exercise. So it basically, squat is a way to improve his ability, in this case maximum strength. While with powerlifters, squat is also expressing his skill. So you need to practice the squat, the depth and everything, preparing for a squat, the openers and all that stuff. So it kind of represents the skill. Hopefully with this simple example you can see how this dichotomization to skills and abilities is kind of blurry, and it's basically representing the as I love to say, a root problem. Again, one more example is we can take West Side approach or Sheiko approach, the Russian approach. For example, if I come to a coach and I say, okay, I want to increase my squat, I think I'm stuck with my squat, and the Westerners are usually gonna say, okay, what's your weak spot? We're gonna attack the weak spot. We need to find specialized exercise. You need to increase your glute strength. You need to increase your lower back strength, and we're gonna throw bunch of different exercises that hit certain components of the squat as a skill. As you can see, it's pretty similar to Rocky and Jean-Claude Van Damme example. On the flip side, if you go to Sheiko, he's probably gonna say, well, you need to do more squat. You need to do more squatting, because you need to learn how to, basically to learn how you can use what you already have and engage the right motor units, coordination between the units. And this is a common theme, in all different sports. As you can see, the simple example between Sheiko and Westside, it can be translated to shot putting, sports, sprinting. Again, with sprinting, you have coaches say, yeah, you need to increase your maximum strength, explosive strength, and then your sprinting speed is just going to increase by itself. I'm not so sure it works that way. You need to put the sprinting and you need to put the skill on top of everything. In sprinting, you need to have a skill of running relaxed when it comes to maximum velocity. Also the skill of exploding through the blocks. It's not enough just to improve the components. This is a usual classification of the motor abilities. As you can see, all the different authors have different definitions. Again, this is to provide the functionality, but again, all those buckets create those problems that we cannot see the similarity between different buckets, and also we cannot see the differences of the components within the same bucket. By starting with the vagueness, dichotomization, and classification and hierarchy, we end up with certain qualities we need to develop. And most of the time, the periodization is about focusing on those qualities. So what we end up, having certain buckets, and now we are worrying about, should I train the skill first or endurance or whatever? And I think that's not the real problem. The real problem is this process is the real problem, and we need to understand it. Is how we dichotomize and create hierarchy and attack this hierarchy so to increase the performance, or in this case vagueness. Hope this makes sense. For example, in team sports, most of our periodization is based on biomotor abilities. If I'm a team sport coach, most of them are forced by courses and academic knowledge to think into biomotor abilities framework and bioenergetic framework, and we are completely forgetting about tactics, decision making under pressure, individual decision making, collective decision making, collective organization, and all that stuff. Those are all components or hierarchies we completely disregarded. So for example, in team sports, we thought, okay, if I increase my aerobic power, my running distance in a game will improve. So my performance will improve. But that's not always the case. And besides that, we also need to think about all those different components that we completely disregarded, including the decision making and technique. One thing also to remember is that we tend to be biased to the things we can measure. Because the physical performance is easy to measure, we tend to focus on it. But that's not the whole story. We lack the, as I said, perception and decision making. That's probably the key to elite performance, especially in team sports and especially in skill-related team sports, than physical aspects. But because it's hard to measure, it usually tends to be disregarded. And as I said, periodization, I think it's a bad word. So I think the planning strategies should be the correct word, and we shouldn't focus solely on these buckets, on biomotor buckets. We need to include lot more components of the performance. For example, in a game, in a soccer game, for example, center defenders need to be able to maintain really high level of focus during 90 minutes of a game, to provide tactical movements on the ball and off the ball, reading the game. And we might have a focus fatigue or concentration fatigue more than his aerobic capacity could be limited him. So again, try to understand how we dichotomize and create hierarchies of the whole performance. And periodization, again, or performance planning, is not solely focusing on certain biomotor or bioenergetic components. It's much more to it, especially in a complex sports. Instead of just worrying, hey, am I doing a linear periodization or am I doing a block periodization? Try to understand how did we end up creating those buckets, and if we hit those buckets, will the performance improve? And try to understand the way how we think and how we come to those conclusions. So as I said, we end up going from vagueness to dichotomies to classification hierarchy. In statistics, this is basically dimension reduction. So in a color wheel, we want to reduce the amount of colors, different colors, in this case maybe 16 thousandths, to something that's more manageable. In statistics, we use usually principal components analysis and factor analysis. And also, for example, if you have a picture, usually the picture takes a lot of space and we need to kind of compress the picture. So for example, we have JPG, I don't know, or GPIG format of the picture. And what we do is take the raw picture, which is probably huge, couple of maybe hundreds of megabytes, and we kind of squeeze it. We lose some variability in this case. We lose some variation in the picture. We lose some precision, but we end up with a smaller picture, and that's pretty much similar with the principal component analysis and factor analysis. It's called dimension reduction. What we are trying to do now, I'm gonna show you an example in R language. For example, this is a sample data. This is our the rows are different athletes and columns are different tests. In this case, we have a back squat, front squat, split squat, bench press, military press, incline press, pull-ups, 1500 meter time trial or average velocity, 5-minute time trial, or in this case mass. This is beep test, vertical jump, row jump, and triple jump. So you have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 tests. In real life it's much more, and instead of juggling with 13 tests, what we want to do is to try to find latent factors, or we want to reduce this into certain buckets. As we all know, this could be lower body strength, this is upper body strength, aerobic endurance, and explosive power. Call it explosive power. This is a procedure I'm going to cover in R. It's principal component analysis, or in this case factor analysis. To be honest, I'm not quite sure what's the real difference between those two, and both of them are trying to reduce the dimensions. In this case we have 13 dimensions into a couple of them that we can easily juggle. So we're gonna continue with our example. What we have here is I already created a script in R language. We're gonna generate some data. In this case I set up, we have 200 athletes, and I'm gonna generate lower body strength data, in this case back squat, front squat, and split squat, and I'm gonna make them correlate. I'm gonna use simple simulation technique where front squat is basically 0.8 or 80% of back squat, and I'm gonna add some random noise. So I'm gonna generate back squat, front squat, and split squat. For upper body strength, I'm gonna create bench press. Same thing with lower body strength. I'm gonna create military press. That's kind of related to bench press, and I'm gonna do it also for 1 mile time trial or average velocity, mass 5 minute, and beep test. In this case, intermittent field test by Martin Bouchet. So this is just simulation of data. In real life, the data might not be so well correlated, but this is just a simulation, so you can see how we can extract those factors. So we have a bunch of variables, and then I need to put them in a data frame. That's a form of data in R. So what I'm gonna do, I'm gonna execute this. As you can see, we created a bunch of data over here, and we have a data frame called testing data. If I open it, we have that table as shown in the presentation. This is the same thing. So we have 13 variables, and we want to make sense of it. If we visualize it, I'm going to create row names. So the first thing to do with the analysis is to plot them. So we're going to create a plot. This is basically a scatter plot between all the pairs of variables. As you can see, back squat and front squat, they kind of correlate because we have something that's approaching a linear relationship or line. And we have back squat and 30-15. This one over here is basically a cloud, which means that correlation is not that high. If we print a correlation matrix, so instead of just showing the graph, we can calculate the Pearson correlation, which we're going to do with simple commands. And we have I can try to do it one more time to make it more organized. So this is basically a correlation matrix. And what we are looking for here is clusters. And you're going to quickly see what I mean by this. So what we're going to do is see what metrics correlate or tests correlate with each other and also don't correlate with others. So in this case, you can see the back squat and front squat and split squat. They kind of correlate with each other, but they don't correlate with things like beep test. I mean, in real life, they should be correlating with vertical jump and broad jump, but just for the sake of example, I made a simulated data so they don't correlate. Again, it's hard to see anything from it, but what we can do is to plot it. And one way to do it is to use ggplot and create a graph. This is a heat map. As you can see on the legend, 0 is zero correlation and 1 is almost perfect correlation. And what you can see is clusters. So what this means is that these back squat, front squat, split squat, they correlate between each other and they don't correlate with anyone else. Same thing for this component, upper body strength pull-ups, they correlate between each other but doesn't correlate with anyone else. Another way to do it is use a heat map function. It's similar, get the same result, but we also have hierarchical clustering we're going to cover a bit later. This is called the dendrogram. The first thing we need to do is to calculate, again, what we're trying to do is to reduce this variability between different tests and try to create some form of latent factors. And that's the goal of factor analysis. What we want to try to do is to extract those hidden latent factors. And there's a fight basically not a fight, but discussion in statistics regarding the definition of factors. So do they really exist? In this case, does a strength really exist, or is it just a way for us to, explain variability, just a basic statistic? And I think it's a simple statistic, and as we said, it's a way for us to organize things easier. But we need to see the difference within those buckets inside. As you can see, there's some variability in that bucket as well. So we're going to use R again to create using a functional principle. We're going to extract. Now the question is how many factors we have. In this case, we're going to create the first model and extract maximum number of factors, and that's number of variables. In this case, 13. Rotation is something I'm going to cover a bit later, and we're not going to do any rotation, and we're going to plot something that's called eigenvalues. I think this is a typo. And create a line over here. This graph is usually used to explain how much factors we need to extract from our data, and usually it's a break, some form of a break that tells us that the right number. In this case, that's 4. One thing we can also use, there are different ways to make sense of it. One thing is to you might take all those numbers that are above 1, and what does 1 mean is that this factor explains same thing as one variable. So using 5 factors is not more meaningful than using. It doesn't explain much variance in our data, or actually it explains less than one single variable. So we're going to use 4, and we're going to extract the factors, and we're also going to use it's not, or can't remember the right name. So we're going to use factor rotation. We have orthogonal factors, which means that we're going to extract factors that doesn't correlate with each others, and that's usually not the case in real life. What does it mean? It means that our strength factor will correlate with our explosive power, and vice versa. So we're going to use a factor rotation, and we're going to create different model, and we're going to print. Let me see. I got some errors there. Yeah, and we're gonna print the results. So we extracted 4 factors and rotated them. So as you can see, these are our factors or components, and these are our tests. As you can see, factor number 1 explains, this is factor loading. This is something that's called, damn, I forgot. So, you know, using this factor analysis, 4 factors, we have 94% explanation of variance in a bench press. That's pretty great. So again, factor number 1 explains a lot of variance in these 4 tests, and we can call this upper body strength. This is explosive power, this is endurance, and this is a lower body strength. I'm not going to go too much into model diagnostics in this case. What you need to check is this H2 number, and we also need to check the model fit. In this case, it's nearly perfect. There's much more about it in Discovering Statistics using our book, if you're interested. Hide this a bit. One thing we can also do is hierarchical clustering, which we already did in a previous picture, but we're gonna do it directly using functions. One thing to also say before proceeding is that these are called factor loadings. If I'm correct, yeah, factor loading, and you know, based on a bench press performance, incline press, military press, we can come up with let's say a factor score for a given individual. Going back to hierarchical clustering, before we continue, we need to normalize the data using z-scores. It's a simple standardization technique, because we cannot compare. We can compare, let's say, a bench press that reach like 150 kilos to a mass that's 17. So we need to kind of normalize them for each variable. And we're going to use a scale function. So we're going to create normalized testing data score, and for a hierarchical clustering we need to create distance. Those are topics that could be covered in different videos or different books. We're going to call hierarchical clustering function, and we're going to use a Ward method. So we're going to plot it, and we're going to circle 4 components. As you can see, it did pretty much the same as factor analysis of principal component. You can see that we have broad jump, vertical jump, and triple jump. What this tells us is that performance in those variables is similar, so they kind of correlate. We have endurance, upper body strength, and lower body strength. Also, these two are more connected than these two. What we can also do, as I said before, now we created 4 buckets. We can also create 8 buckets. Why 4? We can create 8 also, right? And then you can see that within those buckets we have smaller subcomponents. in this case pull-ups and military press kind of differ, even if they are within the same bucket of upper body strength. One way to do it for creating a heat map, I'm going to create it first. This is a heat map of whole data, including the rows are athletes. You cannot see it here, but I can extract it to a PDF. And columns are variables. Here we have a hierarchical clustering of the athletes. We can see the athletes that are similar. Probably we can see the different groups of athletes that are similar in certain aspect. And also here we have the same dendrogram, similar dendrogram. I think it's using complete method that explains the similarity of our variables. And again we have upper body strength, lower body strength, explosive power, and aerobic endurance. Hopefully I explained the creation of motor abilities. Basically starting with some form of a vagueness, so we have no clue what's happening over here, and we want to make sense of it by creating, first of all, dichotomization to motor skills and abilities, and creating a hierarchy. For factor analysis to work, we need to have a lot of subjects, for example, over 200 subjects, hopefully from different populations, not a specialized population, so we can see the different correlation matrix and find correlation clusters. What we end up is basically the buckets of similar performance. So if I'm good in a front squat, I'm probably going to be in a back squat as well. So these kind of correlate between each other and create different buckets. And that's how we reduce our vagueness and create different components. And instead of worrying, instead of thinking in buckets, and I mean, it's easier to think in buckets, but we also need to start thinking about how we end up with the buckets. And instead of thinking like, oh, I'm gonna periodize our strength training using this or that, or how am I gonna periodize the buckets, we also need to understand how everything started from the Big Bang, sort of. How everything started, got dichotomized into two dichotomies, and how we proceeded to create a given hierarchy and structure. And we need to understand that process to stop thinking about explosive power, because it can explain certain things, but after or under certain level, but after that it can't explain and can help you much with the programming and planning strategies. Hopefully this makes sense. At least I hope I haven't confused you too much. And looking forward to new videos.